So, I recently did a video of what happens if you've got an antenna on the slope of a ground. What happens going away from you? And then somebody asked the question, what happens if you've got a hill or a mountain, behind you or over there, whatever. So it's actually quite an easy way of working this one out. Now let's just draw this and we'll go through some concepts. Now, a lot of what I'm going to say doesn't really apply to VHF. So that's your car stereo, microwave, things like that. And the reason being, I'll get a red pen. Reason being is that if you just take a hill, whatever, and you've got some sort of antenna here, and you're on the other side of the hill somewhere, block of flats, I don't know, apartments, then between here and here, each side there is effectively what they call a radio shadow, right? Now, just like when you come over the brow of a hill at night, with your car headlights, there is a bit of, on the one hand, it's not so much refraction, but I think what's happening is that the light is picking up particles in the air, and you can see it is kind of reflecting. But there will be a little bit of refracting too, particularly, I think, on HF. So, do I keep this paper or carry on? Let's go to kind of just principles. This is not so much for if you're a consumer watching this. I mean, you might find it quite interesting. If you're a ham radio operator, hopefully you'll find it more interesting. I want to just get into where is your radio signal going? At what angle, if we really did have a slope, all right, that went up a hill, effectively, and you've got an antenna here, what can you expect? There we are. What can you expect to receive if you were restricted to, let's say, 5-10 degrees, all right? And how do we work that out? You live here and there's a big hill over there. What is the angle between the two? We'll work that out in a minute. But where is the DX? So the DX in the main is anywhere between 3 and 8 degrees. It could be higher, could be 15, 20 degrees. Some DX on 80 meters has been demonstrated to be even as high as 20 degrees. But in the main, let's take a baseline. We can't use 5 degrees because we very often will be on a 5-degree slope if we're worried about this problem. But let's say 10 degrees, right? What can we expect to receive on 10 degrees? Now, you will receive some, because if there's all these signals coming in, let's plot it out. So we've got, let's say, 3, 6, 9, 12 degrees, 15 degrees. You'll find there'll be like a bar chart. Now, I don't know, there might be one on the internet which we can have a look at, but out of 100 stations, let's say, most of them are probably going to be somewhere in there. 3 degrees is going to be less, 12 degrees is going to be less, and 15 is going to be less. So most of our DX is probably, it's probably somewhere between these points, okay? So if you've got a hill in the way, which is 10 degrees, about there, yes, you are going to get some DX, but just not as much as the guy who doesn't have a hill over there. Maybe that solves some of the problem. But how big is big? So I'm on Google Earth here. I think we can probably get rid of this now. I'm on Google Earth here, and I just happen to know this is a country park over here. It's very nice, and it's quite high up. So I'm looking at the very bottom right of my screen. When I hover over here, it's telling me it's as good as, in fact, there is, I think there's it's 299 or 300 meters. Could be feet, doesn't matter, all right? So let's draw a line from there, and let's just imagine we live in one of these houses over there. It's telling us that line is, there we are, 838 meters. Now let's just measure the height of this man down here in this house. He is at 226, it says at bottom right, and we know it's 300 there. So that is going to be about a 75 meter difference across 800 meters. How do we check what the angle is? So, I found this here, angle of elevation calculator. It's easy. So the two heights, one from the other, that was 75 meters, we agreed. There's a 75 meter difference. And the distance of the object, if you remember, was 838 This could be feet, miles, it doesn't matter. 8:38, and the angle of elevation between these two is 5 degrees. So I won't go back to it now. So he is going to be at a disadvantage because he's not really going to receive much above 6, 7, 8. You've got something else called Fresnel zone also, which probably wouldn't matter actually thinking about it but he would be at a disadvantage, would you agree? Because he's already got a 5-degree angle before he starts, right? It just so happens that one of the reasons I picked that, because if I'm in the UK here and I want Florida, well, most of America, just above there actually, it's about 290, 295 for us, to the US. So there we are. That's what happens when you've got a mountain. So the original question was, I've got all these mountains near me. Well, measure it all. You might find it's not as bad. Maybe 3 degrees, in which case, it doesn't matter. What antenna is best for this? Again, it doesn't matter. Whatever antenna you normally use, will do the same job, whether it's there or not, less the 5 degrees we've got here. All right. Sometimes you just got to think these things through. It's quite interesting. The URL and stream key is missing. Well, I didn't know I was streaming, but thank you very much. Okay, well, that's all right for this time. I will see you on the next one. Here's the next video. Bye for now. That's a weird error, wasn't it? Hopefully we've recorded this.